So what shall we do next?
So we did common emitter with resistor biasing. We did common emitter with current source biasing, and we did the current mirror. I wonder if there are any other circuits that we can look at, no? With common emitter.
Yeah.
Right?
So this was an amplifier we started.
Correct. Inverting amplifier.
To amplify the small VB
Small
or
VB.
Vm sin omega
Correct.
T we mentioned.
Correct. So we had Vm sin omega T. We wanted to give it to some amplifier.
Yeah.
Right?
Correct.
And this happened to be some minus GM RC or whatever it is. But this is what we got. That is correct.
Now in some applications, I may have two voltages.
Okay.
Maybe Vm1 sin omega T and Vm2 sin omega T.
Okay.
And I may want to amplify the difference alone.
Oh, I see. Okay. Okay. So you want to amplify the difference.
Yeah.
I see. Okay, let's look at that. So you are okay. So if I and okay, so okay, let me draw it slightly differently. We can draw it like this, no problem. So you are, so this is, let's say, V1
Yeah.
and V2.
Correct.
And you want to amplify V1 minus V2.
Yes.
So this
Let's
is,
say VD, the difference voltage.
okay. So you want to amplify VD. Okay, so let's see how to do that. So this is easy, no? So conceptually,
Yeah.
easy.
But how to get that summing node or difference
that's
node?
right. That is right. How do you do the difference?
Yes.
Okay. This looks easy because it's A, but we don't know how to do this, right?
We can do two A's separately, but still subtraction, I don't know.
That is correct. We can do two A separately, no?
Yeah.
So that is also one way of doing it. So let's see.
But still we need to subtract.
You need to subtract. You need two amplifiers. You still need to subtract.
Yeah.
Right? You could do something like this, no? That's what you're saying.
Correct.
So you could take V1, you take V2, same gain A, and then this would give you VO.
Yeah.
We could do like this, correct? This will also give you A into V1 minus V2. That is what we wanted.
Yeah, that's what we want.
Right?
Yeah.
So we want V1 minus V2 times K. Well,
Yeah,
but
between two terminals, if we have the
if we have
VD
it.
amplified,
Correct.
that's enough.
then we can just start with this, no?
Correct.
Let us start with this.
Correct.
So what I can do, okay, how do we get A? Now A can be minus GMRC.
That is true.
Shall we just start with our common emitter amplifier?
Actually, if you have two common emitter amplifiers,
We can
what
just connect
you
them
have drawn-
together, correct? We can just
okay.
connect them together. So, okay, so let us try that.
Yeah.
So I am just going to take two common emitter amplifiers. Okay, so this is, since we want A times V1 minus V2, you want same A, no? So
Yeah.
I am going to assume RC is the same on both sides.
Yeah.
That is easy. So then, so okay, R1, R2.
Yeah.
Okay, and here we will given the two inputs,
Yeah.
V1 and V2, no?
Yes.
Okay, what do we do with this?
There, in the previous case, we have graduated to giving a current
Current
source.
source. So we'll do the same thing.
You can do that, no?
Correct. And in fact, correct. We can do that, no? So
You want to give it separately,
separately,
or
maybe we'll start with, well, mm, see, I'm looking at this. So let's say, let's give it separately. Suppose I gave it separately, no?
yeah,
What I am seeing is that for DC, this voltage is the same.
yeah.
This is both VBE here. These two voltages will be the same at DC.
So even you can connect them.
I can
together.
connect them. Nothing will happen for DC,
Correct,
no?
correct.
So let us just draw it like that. We don't need two separate current sources.
Yeah.
Right. So maybe what I can do, I just it's enough if I have one current source.
Yes.
Right. So we just draw it like that. One current source. Right.
Yeah.
Maybe I'll call it 2 I0 from now, but it doesn't matter, no?
Yes.
So I'll just get I0 in two sides.
We are assuming that match transistors and then
Correct. So
RC,
we are assuming
RC,
that
they are
Q1
same.
and Q2 are identical,
Yeah.
RC and RC are identical, and so on.
Yeah.
Right. And finally, we also don't need the capacitor. Right. Students may be wondering what happened to the capacitor. We also don't need the capacitor also, because what happens is that the capacitor is going to give you a AC ground there.
Correct.
Here again, these two voltages are the same for both signal also.
Yeah.
Right. So we don't need the capacitor. There is going to be no AC current flowing through the capacitor anyways. Right.
Yeah.
So for DC, the current will be the same. For AC also, we'll leave it, we'll remove the capacitor.
And output, where we will take?
Output,
RC.
we said between the two
Correct,
terminals.
correct.
So we'll just take it like this, no?
Okay.
And maybe we'll take the difference like this.
Yeah.
Right. So since we said VD, no? Shall I call it VOD? Output differential.
Yeah.
Yeah.
So
and maybe I'll call this VID, or VD is fine.
VD is fine.
VD is fine for the input. Okay, this is VCC. So basically, there is going to be DC's position is the same voltage, so we connected it. And for AC also, there is no current through the capacitor, because these two halves are getting two equal and opposite sides. That's what we said, right? We want to take the difference between the two. Okay.
So can we also write expression for individual outputs just to get a feel?
We should. So we'll call that VO1 and VO2. Maybe small. I'll use the small symbol.
Yeah.
We need to.
Yeah.
We should definitely write the individual expressions. Okay.
So VO1 is.
You want to do it for the signal, right? With the or the total one.
Actually, from the previous explanation, we know that it's a GM VBE.
Correct. That's right. So we can just write for small VO1 and small VO2.
Yeah.
Right.
And we were saying we wanted to amplify the difference, VD.
Correct. That's right.
VD is the difference volt between these two inputs.
Between these two inputs. Correct. That's right.
So that way, can we say VD by 2 is the voltage at one side, and
we can say that because actually now I am seeing this. We wanted V1 by 2 and V1 and V1 minus V2, no?
Yeah.
So this will, you can just say that the whole circuit is symmetric, and you can say that you are applying VID by 2 and minus VID by 2 here, VD, right?
Yeah.
And minus VD by 2.
Yeah.
That's right. That is exactly the same because the circuit is completely identical.
Correct.
Right? So in fact, I can see total symmetry on now on either side, except everything on one side is negative, everything on the other side is positive.
So that way V01 is
negative of V02.
Yeah.
Right?
Yeah.
And
in also fact, V01 in terms of input is
correct. It will just be GM of transistor 1 times RC.
Correct.
Right?
Into VD by 2.
Into VD by 2. Correct. So then VO1 will be minus GM1 RC into VD by 2, and VO2 would be minus GM2 RC into VD by 2. right, into minus Vd by 2.
Yeah.
Right. So if you take VO1, VOD, no, will be VO1 minus VO2. We said plus minus.
Correct.
And that will become this minus this, no. So it will basically become minus GM1 RC into Vd.
Okay.
So this is the classic expression for the gain of this differential amplifier.
Differential amplifier.
Correct. So this circuit, maybe I'll write it here. So this circuit amplifies the difference between V1 and V2.
So if V1 and V2 are same, then output is 0.
Output is 0. Correct. If
So
you correct.
that means it
Because you can see that, no, here if you gave instead of Vd by 2 and minus Vd by 2,
yeah,
if you just gave Vd by 2 and Vd by 2, then if you take the difference between VO1 and VO2, it will just give 0.
yeah.
Correct. That's right.
So that means something which is common
That is correct.
is rejected.
Is rejected.
Only the difference is amplified.
Only the difference is amplified.
Okay.
That's right. So yes, so that is called the common mode rejection of the differential amplifier.
Okay.
Correct. Correct. So that is a very useful property. In fact, if you did not remove this capacitor, that common mode rejection would not happen. It is very important to remove that CE so that you actually allow this node to float. Otherwise, if you put this, it will just be two amplifiers sitting.
Correct.
Right? You will not get common mode rejection.
So this signal current will Q1 that is coming and that is coming through Q2 will get cancelled.
Correct. That's right. So it's almost like signal current is going back and forth between Q1 and Q2. That's right. So if you write down the expressions for the currents and voltages, if you give Vd by 2 and minus Vd by 2, all the voltages and currents on the left side will have a certain sign and magnitude. All the voltages and currents will have the same magnitude, opposite direction. So that is why if this current is small IC1, this current will be minus IC1 flowing downwards, which is IC1 flowing upwards.
Yes.
Correct. And actually this is called the half circuit, right? So this portion is called the half circuit. So very often you can split the circuit in half and analyze it to understand how the circuit will behave.
You were saying common mode rejection.
Yes, correct.
Common mode is
common mode
so
is.
we mentioned about a condition where Vd is 0.
Correct.
That was easy.
So, correct.
So that's the common mode signal.
That is a common mode signal.
So when Vd is there,
you are giving a differential mode signal. Correct.
So but there can be situation where common mode signal and Vd are present.
That is correct. In fact, the most general way to analyze this is to assume it is V1 and V2. Then if you give in general, so if you give V1 and V2, so if you give V1 and V2 as the input, so maybe we will draw it like this. So now I am going to show the differential amplifier like this.
Oh, what is this?
Differential amplifier. Earlier we only did this, single-ended amplifier.
Correct.
I gave Vi, I got Vo, which is A times Vi. Now I am going to draw this.
Legs and hands.
Exactly. It is a four-legged animal, not a two-legged animal. Right?
Okay.
So now I can give Vid by 2 and minus Vid by 2. Right? You want a difference, no?
Yeah.
I'll show it like this.
Okay.
And this would now be Vod, which would be A times Vid.
Yeah.
So something like this. Now, the most general way of analyzing this, the same thing would be like this. So I give V1 and V2.
Yeah.
So now your VO, actually now you need to find out, you are interested in A into V1 minus V2.
Correct.
But you may also get, if you give not just plus Vd by 2 and minus Vd by 2, if you give some V1 and V2, no? So you are interested in this, but
Correct.
you may also get this component. And this is your common mode component.
V1 plus V2 or V1 plus V2?
Technically V1 plus V2 by 2.
By 2.
So that is, we will write it like that. The common way of writing it is V1 plus V2 by 2. So B into V1. So that's why I wrote it as B into V1 plus V2, but you are right. B into V1 plus V2 by 2. And that would
No,
be
I
a
was
common
comparing
mode.
with giving same signal.
Correct.
So if I had to get that value, it has to be
Correct.
V1 plus V2 by 2.
That's right. That is right. Because if you give the same V1 equal to V2, then this will go to 0.
Correct.
Right?
Correct.
But you will still get output on each side. Right?
Ideally, I should not get.
Ideally, if you take the difference, you will get. You will not get.
Correct.
But on each side, you will get something.
Each side.
Correct?
Each
So
side.
technically, if you want a purely differential amplifier, even on each side, you should not get anything. Right? Ideally. Ideally.
So the common mode signal is sum of these two by 2.
Sum of these two by 2. Correct.
And this common mode rejection, you said that's
Yes.
something to do with A and B?
Yes, correct. It is, you ideally want your common mode rejection, no? So maybe I'll call this CM and DM, right? So your common mode rejection ratio is basically going to be, you want to see how much the common mode is rejected with respect to the differential mode. So you're basically giving some arbitrary V1 and V2. You're trying to find out how much of the output is only V1 minus V2. You don't, so you want A to be large, B to be small.
Okay.
Right?
So B is the gain for common mode signal.
Yes.
And A is the gain for difference.
That's correct.
Okay.
So we'll call it, I think the textbooks use differential mode, no?
Yeah.
So they may use ADM
yeah.
or ACM,
Yeah.
right? Those are the common ways of doing it,
Correct.
right? ADM and ACM
So this ADM by ACM is
the common mode rejection.
okay. Ideally, you want this to be very large.
Very large, as large as possible. In fact, ideally, if everything works well, you want B to be 0, right? So that will work out very well.
So this amplifier is very nice then.
This is a very amplifier.
Something which is common, it rejects.
That's correct.
Amplifies only the difference.
Very useful amplifier.
Can I see that once again?
Yes, of course.
So okay, Q1, Q2 they are matched, R1,
They are
RC
matched.
matched. So I note will flow
On
through
those
each
sides.
branch.
Correct. Correct. That's right. So let us draw it separately here. So if you look at the, as you pointed out, so the current through, if this is 2 I0, the DC bias point through each will be I0. The DC voltage here will be VCC minus I0 RC. Here also will be VCC minus I0 RC. The DC voltage here will be R2 by R1 plus R2 times VCC. Same thing here. So it's symmetric, right? So everything should be symmetric on all sides.